Whisky is one of the most coveted of human-made spirits, enjoyed by a uniquely enthusiastic fan base that will queue for hours to get a taste of a rare dram that boasts unique properties. But what actually goes into the amber nectar, and what can science tell us about how the way whisky is made alters the flavour? We travelled to the Glasgow Science Centre in Scotland to find out about the science of whisky, which, as luck would have it, is a talk that the museum regularly hosts. Presented by Science Operations Manager Steve Owens and Roddy Graham of the Good Spirits Company.
My name's Steve Owens. I'm the Science Operations Manager here, one of the astronomers that works in the Science Centre, and I'm an amateur whisky enthusiast and like bringing whisky and science together.
My name's Roddy Graham. I work at the Good Spirits Company, which is a drink specialist here in Glasgow.
When we talk about whisky, what is it and what's in it?
So whisky means a distilled spirit that's made from grain. Single malt Scotch whiskies is made only from barley and made here in Scotland. You start the process by malting barley, where you unlock the sugars and then you grind that up into a kind of coarse porridge and you make beer. And then you distill that, so you're concentrating the alcohol and getting rid of most of the water. And then you put that in barrels for, in Scotland, a minimum of 3 years. And then it's whisky. It's much more complex than that, but that's the shortest version I can manage.
I think one of the best things you can do is go to a guided tasting, so that there are people who are passionate about whisky and understand what we're talking about that can guide you through the process. And almost always when you go to a tasting, there'll be a range of whiskies. The whiskies will change from glass to glass, and you'll usually be started with the slightly more gentle whiskies, and as the night goes on, your palate will adjust, your tongue will become a little bit more used to drinking the whiskey, so you might be a bit more prepared for the whiskies at the end that are a bit more robust or challenging or smoky, and finding the distillery that matches your palate, because everyone's different.
Well, when Steve and I do our event here, the 6 whiskies are all picked. Taste different. We taste them in a sequence, as Steve says, from the lightest to the punchiest. But we encourage people to not finish each one in turn, but to leave some so that you can go back to it. The contrast in flavour is accentuated, and then after you've tasted 6, you might be a little bit fuzzy. Mm-hmm. You've got a better understanding of the range of flavours. Taking notes is another thing, because then you've got to try and convert flavours into words, which is tricksy.
Yeah.
But taking pictures of the ones that you've had, and that then the visual memory, when you look at the pictures, that triggers the taste memory.
And there's a lot of science and culture to whiskey. This is a thing that has been around for a while. What do you know about kind of the history? How far back does whiskey go?
Distillation's been is probably 2,000 years old. There's documentation that shows that it was in Italy by about the 9th century. And Southern Europe, they would have been distilling from wine. So as that knowledge moved north, then it would be more likely that people would be distilling beer. There's some documented evidence to suggest that whisky was being made in Ireland in the 11th century. Firm evidence from 1494 of whisky being made in Scotland. That's an entry in the Exchequer books for the king to send barley to monks in a monastery in Fife to make aquavitae for the king. Aquavitae being the old word for birit. So that's over 500 years.
And that word we talked about a lot tonight, spirit. The initial distillers who were doing it 2,000 years ago, they were trying to get the pure essence, the soul out of the whiskey, and that's why we call spirits, because people thought they were getting access to the spirit character, the soul of the liquid.
We have all these kind of new technologies and toys for making whiskey now, but has the process really changed that much in that time?
Quality of the liquids, most people would agree, is better and it's more refined, but essentially you've got 2 giant kettles and a few giant buckets. Your giant bucket is to make your beer in, the 2 giant kettles is to boil it up to concentrate it and make the spirit, and then it goes into the barrels. It looks very sophisticated. You go to a modern distillery and there's touch screens and computers, but all they're doing is the same as was being done 200 years ago.
But not all modern distilleries are doing that, right? There are still some distilleries that are doing it the same way they would have done it 100
by hand, say. Yeah. But some of the new craft distillers who have come up in the last decade or so, they're trying to go back to that way of doing it. It's been made more efficient in terms of the yield, but these modern practitioners of the old method, they're giving up efficiency in exchange for flavour, because they want to try and rediscover the flavours of whisky from that long ago.
And when people talk about having kind of double and triple distilled whiskies, what does that mean?
In terms of whiskey, you boil it once, and that's a preliminary stage where you're essentially getting rid of a lot of the water, but you're not really trying to refine it.
And you're boiling it in these designed to shape copper vessels.
They are essentially just kettles, so they're giant kettles. And then the second time that you boil up, that's a much more careful process, much more tightly controlled. You're choosing which parts of the liquid you want to keep. So that's double distillation because you've done it twice. And then some distilleries will then do it a third time because they want to refine the liquid still further. Or, say, in Ireland, the tradition is nearly always to triple distill.
And for the engineering, it sounds like it's got a lot of steps to it. How does that process alter the kind of flavour of the end product?
The shape of that copper kettle, these stills, can really define the flavour character of the whiskey. Fatter, squatter, dumpier stills, you'll get a kind of maybe a more robust, maybe a bit more challenging flavour. If you have a tall, elegant still with a very long neck, then that produces slightly more refined, lighter whiskies. Yeah, so good examples of two to compare. Lagavulin Distillery at Islay has very, very squat stills, making a very robust, delicious whiskey. And Glenmorangie, they're amongst the tallest stills in the world, and they make a very light, kind of refined, delicate whiskey.
How does the geography impact whiskey?
The geography of Scotland lends itself to making the spirit. If we were further south, if we were a Mediterranean country, we'd be making our booze out of grapes rather than out of grain. We can't grow grapes in Scotland, so we grow barley instead, and that ingredient is the fundamental ingredient of whiskey, but there's a lot more to it than that.
Japan, for example, modelled its whiskey industry on Scotch, and has a broadly similar climate. When you taste the two side by side, you would see that Japanese whiskey sort of tends to be more refined. The Scotch whiskey, I thought, has always got a little bit of a burn to it. If you look at American whiskey, they use corn and rye, which we don't in Scotland, so they have different flavour profiles, but then the main whiskey regions in the United States are drier, so the whiskey matures more quickly. So you find typically that American whiskey is a bit spicier than Scotch.
And the same is true for Scotch whiskey in other countries as well. So if you go to countries with a warmer climate, they might make single malt whiskey using the similar processes to us. But because their climate means the whiskey will evaporate quicker in the barrel, they have to bottle it quicker, so it tends to be younger. You get less wood contact, you get a different profile of flavour.
The Amrut distillery is probably the most famous. They have to bottle them when they're 4, 5, 6 years old, because otherwise there'll be nothing left in the barrel.
So there are perks to all the grey weather then.
Yeah, and the rain as well. You know, we wouldn't have whiskey without the rain. The climate we have here is perfect for the kind of growing seasons for these for the crops that we use for whiskey and for aging it too.
When it comes to the end product, the whiskey, would you say it comes more down to the ingredients, or is it just about the process?
There's so many different stages to the process that can influence the whiskey you get. So you have flavour profiles imparted from the ingredients that you're using, from what you do with those ingredients, how you malt the barley. Sometimes distilleries use peat to dry the barley, and that imparts a very smoky flavour. You get compounds released during the fermentation process, making the beer that Roddy was talking about, unpleasant beer. Compounds removed during the distillation process, removed by the copper contact, and then further compounds removed and imparted to the whiskey in the barrel. So there's so many different stages to it. That's why I love whiskey so much. The almost infinite combination of flavour.
In terms of malt whiskey around the world, geography does make a difference, but also culture, and I think the Japanese malt whiskey industry was very decidedly modelled on Scotch, but the end result is different, and I put that down to the culture in terms of what the distillers want. There's infinite variables, so it's it's geography, it's process, and it's culture as well, I think.
People who are not familiar with whiskey think all whiskies taste the same, which broadly speaking is all whiskies burn and don't taste pleasant if you're not into whiskey. But having been collecting whiskey and drinking whiskey for a long time, I can appreciate whiskey in a way that I can't appreciate any other food or drink. It's something I'm really passionate about, I really love, and I've learned to identify different flavour profiles, different whiskey styles.
So I have described myself as someone who is just getting into whiskey, and I'm interested to know, when we're drinking it, what are the things that we're tasting?
There's a whole bunch of things that and every stage of the process of making whiskey changes, mostly adding but also subtracting things. So the barley that we start with, you can taste the barley. Then the malting process, that's that malt flavour that we recognise from beer or from malt loaf. Then there's the fermentation process, which gives you more beery flavours, and that's kind of where all the fruity flavours come from, the esters. If there's lactic notes or sour notes in your whiskey, that's from the fermentation. And then the distillation, that concentrates those flavours. but it also separates out some of the ones that we don't like. So Steve's talked about the copper, and Scotch whisky uses copper because it wants to focus on pulling out sulphur compounds, which we really don't enjoy the flavour of. And then once you've distilled, it goes into barrels, and obviously the barrel imparts the flavour of the wood, like humans love the flavour of oak. It's vanilla is the big important one, but it also subtracts flavours, mainly sulphur compounds. And then because the barrel's porous, the liquid also oxidises very slowly. So all through the whole process, the years it takes, you're adding and subtracting different flavours.
And then sometimes distilleries or bottlers will chill filter the whiskey to remove some compounds that make the whiskey look less good on a shop shelf. But that is removing some flavours too. And I would always prefer a whiskey that was non-chill filtered, that didn't have those compounds removed. And they remove them because if you don't, if the whiskey gets cold and stands on a shelf in a storehouse, it'll go cloudy. People think cloudy whiskey is off or bad, but it isn't. It just happens to be cold. If you warm it back up, it would go clear again.
Whiskey drinkers like myself and Steve, we would always look for a whiskey that was labelled as non-chill filtered, because we know that we're going to get more flavour.
You mentioned there about the barrels, so the aging process, that's an important thing for whiskey.
What it boils down to is that people know that whiskey is better when it's been in barrel. So that's been then written into the law, and it's been in the law long enough that people know that up to a certain point, whiskey will improve in the barrel. And it's different for every distillery. Every distillery has got a kind of an optimum age, and that's something that whiskey enthusiasts will often argue about over a dram meaning is what's the best age for a whiskey.
And it's a broad rule as well, isn't it? So it doesn't necessarily mean that because a whiskey's young doesn't necessarily mean it'll be less flavoursome.
Islay whiskies are always better younger, whereas in Speyside whiskies I would tend to want them to be older. The barrel process, I think, is important because there's so many different things going on. There's this subtractive aging that improves, that takes out the jaggies, as I call them. There's the additive process where you're getting the flavour of the oak plus whatever was stored in the barrel previously, and then there's the oxidation that just changes the compounds that are already in the liquid. So if a whiskey was fruity in style, then if it was young, it would seem more like fresh fruit, and then the longer you keep it, it would start to seem more like dried fruit. And that's exactly the same oxidation process that with the actual fruit itself.
But there's a lot of commercial aspects to this as well. There's a commercial imperative to get the whiskey out and to bottle it maybe at younger ages than they might want to, or bottle it without an age statement that allows them to release stock and make some money a little bit early in the process. And also the type of barrel they're buying. So barrels are traditionally, it's across Scotch malt whiskey, sherry barrels, but people aren't drinking as much sherry anymore these days. So you find less availability of sherry barrels, and therefore we're broadening out to each whiskey in rum barrels or ex-wine casks or beer casks sometimes, and there are lots of different ways of aging whiskey, and those are commercial decisions. They result in a lot of interesting flavours, but they're modern divergence from the traditional sherry barrels.
Is there a limit to how many kind of times and varieties of barrels can you feasibly take a whiskey and put it through barrels of several different?
You probably wouldn't, because every time you're moving liquid around, that costs you money. Distillers will select barrels to fill to start with, in the hope that all they have to do is put the liquid in and then take it out and bottle it, and then that's the least amount of money spent on process. You'll sometimes find, and especially the kind of whiskies that Steve and I are interested in, which are produced on a smaller scale, where the producer can think about an individual barrel rather than 100 barrels are being vatted together to make a large-scale product. They'll find 9 barrels are lovely, let's say, and the 10th is kind of lacking something. So then that's when you would move it into another barrel to try and add another layer of flavour to it.
You mentioned the jaggies, and I think one thing anyone that's ever drunk whiskey can understand is that sort of burning sensation you sometimes get when you drink it. So what's going on there?
There's a couple of different things that are happening, and one of them is that we have receptors in our tongues that have evolved to allow us to detect us drinking hot things, and the alcohol in whiskey allows those receptors to activate at a lower temperature. So at room temperature it feels like our mouth is burning, like it would if you're drinking a hot cup of tea or something. So those receptors misfiring effectively in the presence of the alcohol are why your tongue feels hot, your mouth feels hot when you're drinking whiskey. But the jaggies Roddy was talking about are a slightly different thing.
Because making malt whiskies it's not a super precise process. You're starting with a certain amount of liquid and you're discarding most of the water, but you can't discard exactly what you want, which is why you have the barrel aging process, because this continues to remove these unwanted compounds. And the jaggies are sulphur compounds, and that's where you get that burning sensation in your mouth.
You can sometimes get if you're not used to drinking whiskey especially, get that burning hot mouth sensation even with fairly smooth whiskies. But the extra jagginess, the extra sharpness is coming from these sulfur compounds that can make it feel rough or sharp.
Given the environmental considerations of using peat in the whiskey making process, some scientists over at Heriot-Watt University in Edinburgh are exploring using coffee grounds as an alternative.
So we're at Heriot-Watt University in Edinburgh, and I'm joined by Dr. Dave Ellis and Dr. Rory McIntosh. If you guys could just introduce yourselves and tell us a bit about what it is you've been doing.
So, Dave Ellis, I've been at Heriot-Watt now for more years than I care to remember, 20 odd years. And traditionally I've been kind of a traditional chemist, I guess, making stuff and measuring them. But a few years ago, along with Rory, we got into looking at alcoholic beverages. We're using techniques that other people hadn't really used before. 6-7 years ago, where we started to think about whiskey and the future of whiskey, particularly peated whiskey. And that's really where the kind of project that we're doing now has come from.
I'm Rory McIntosh, also an academic in the chemistry department. And like Dave, I have a background in inorganic chemistry, so catalysis and making polymers. We combined our expertise to look at some different projects out of necessity and partly out of fun.
So for people who aren't familiar with the role that peat plays in whiskey, why is it so important?
If we're going to turn grain into whiskey, we want to take the starches that are in those grains, convert them to sugars and then ferment those sugars into alcohol. The way you do that is you allow the grain to germinate and start to do that, and when it wants to grow, it's going to convert its own starches into sugars, take those sugars and make alcohol. And the way you do that is in a process called kilning. So sometimes if you go to a distillery, you'll see them have these large open rooms with the grains all spread out on the floor, and they've usually got some sort of heating system in there in order to raise the temperature and just stop that process happening before they then take those grains off and ferment them. A traditional way to do that in Scotland was to use peat, which was readily available, and people could cut peat themselves and use that. A lot of the distilleries now just use a kind of gas heated system and use that, but predominantly Islay whiskies. Islay is an island off the west coast of Scotland, has retained this kind of peaty characteristic in their whiskies. So they're taking that peat, burning it, and the heat that's generated from that to do this kilning process. A kind of unintended consequence of that is then that smoke that's coming through carries with it a lot of chemical compounds, and those chemical compounds eventually find their way into the final whiskey. And it gives the whiskey that very characteristic flavour profile.
Chemically speaking, what are the things that we're tasting?
Benzene is the most simple of them. Phenol is one with benzene with a hydroxyl group on it. The flavour compounds are kind of derivatives of those. And each of those has its own flavour, its own aroma. Cresol has a kind of antiseptic, it sounds not particularly appealing. The phenol itself is kind of medicinal. It's sometimes described as syringols tend to be spicy. The makeup of those phenols generates the profile of the final whiskey. One of the big kind of conundrums of whiskey science is that connection between sensory and the chemical composition.
Why is it that it's good to be considering alternatives?
Peat's a carbon sink, so there's a lot of carbon stored up in there, and it actively continues to store carbon from the atmosphere.
Healthy peat is very good at storing carbon. As soon as peat starts to degrade, then it actually starts to extrude carbon. So healthy peat is a very good thing. Unhealthy peat is very negative. It's not a limitless resource. It will eventually run out. And in terms of the whiskey application of peat, you can't just use any old peat to get those characteristic flavours. You have to use peat that's quite near the surface, so it starts to go down deeper and deeper. The chemical profile of the peat changes, and that impacts on the spirit. And the number of peat lands in Scotland now which are used for extraction to make whiskey has shrunk massively to about 3. From dozens and dozens some years ago.
It's important for biodiversity as well. This is another part of our ecosystem that we're removing, and peat grows at around about 1 millimetre a year. So it really needs to be thought of as a non-renewable resource in the same way when we're digging up coal or oil, it forms over millions of years. Peat's kind of the same.
And as I understand it, you've been exploring coffee as a possible alternative. So what led you in that direction?
We were looking at some peat and we were looking at coffee by a technique called NMR spectroscopy. and we realised that their spectrum, the kind of profile that we see when we look at them, was actually quite similar. And that started out a conversation as to whether, potentially this was something that could be used as a replacement for peat.
The kind of biomass of peat and the biomass of coffee are quite similar. So they have lignin and cellulose and things like that. And we believe that the small flavour compounds that come out of peat that generate these smoky flavours in whiskey caused by this cracking of these biomass units.
Yeah, and the things that were attractive about coffee is that there's huge quantities of waste coffee around. So taking something which is a non-renewable resource and replace it with something that is currently here, it's abundant and isn't really being used for anything. So to begin with, we just took some coffee from the coffee shops on campus and just kind of took it all together as a bit of a mix before we dug down deeper into it.
We started to use kind of traditional chemistry pieces of kit, which may not be that commonly used in the industry. And my background is in nuclear magnetic resonance spectroscopy, which is a very, very traditional technique to try and identify structures of molecules. But it's also very good at identifying complicated mixtures, because each component of the mixture, for example, if you had a whole load of these phenolic flavor compounds, each of them would have its own NMR profile. Traditionally in the sector, if they're interested in quality control, for example, they would use mass spectrometry related techniques to look at certain selected markers. And whereas with NMR, you can look at a whole range of compounds in the whole mixture. But having said that, as the project has developed, we've realized that NMR may not be sensitive enough to look at the real kind of granular differences in samples. And so ironically, we've kind of come back to using mass spec techniques in conjunction with NMR and other solid state techniques like GCMS, where you actually burn the peat or the coffee in the absence of oxygen. So it's not really burning, is it? Pyrolyzing, and then you can identify the compounds that come off that. So that kind of mimics what happens in the kiln. By tracing the progress of all these chemical species through that journey, you can develop more of an understanding of the link between the spirit and the peat or the coffee or the wood or whatever you started. One of the advantages of NMR is very simple. You can get hold of little NMR tubes which are 5 millimeters wide and about so high, and you dissolve up your compound or mixture in a solvent, something like peat or coffee, for example. What we would normally do is, because we can't dissolve peat in solvents easily, we would normally extract compounds from that, and that will pull out these phenolic compounds and other volatile organic compounds, small molecules that we would be interested in. Most NMR these days is purely run through automation, so you don't even have to create experiments. The experiments are already there. Stick the sample in some kind of robot sample changer and then go and have a cup of coffee. Come back and the spectrum is done. So it's actually very, very simple. And although the experiments that we used quite sophisticated as NMR experiments, they still only took 10 or 15 minutes each. The hard bit is then interpreting the data that comes out of it.
Some of the other techniques that we mentioned earlier on, like some of the chromatography techniques, you're separating out different compounds, and then these elute from the instrument, and you see some sort of peak. The peak in that case doesn't tell you what the compound is. You know what compound it is based on the time it came out at. NMR is different in that regard, in that it's giving you a kind of chemical fingerprint of that compound. There's more information than you would get from some of these other techniques. There are some NMR techniques that use solids, but for the most part, it's a liquid phase technique. So if you're going to take something like peat, I can't just put peat straight into this tube with some liquid and run an NMR spectrum. There's a slight restriction on what you can look at, which is why Dave was mentioning there, doing an extraction and seeing what small molecules come out when you do that, or can we take the smoke it produces and trap it and let out the smoke of the compounds that are coming off in that way.
And with the methodology you've been using, what has that now told you about the kind of compound similarities between peat and between coffee?
When we looked at the flavour profile, the sensory profile of those whiskies, there was a number of strong matches with what you would expect a peated whisky to taste like. But there's a couple of differences in the kind of smoky characteristics of it. And we think we know where that comes from. There's a few extra compounds that are in coffee that aren't in peat. Having said that, I think because this was just our first attempt at trying that probably there's a number of refinements you could make in the burning process and the malting and the kilning and all the various different stages. There's also a question as the whisky matures, which compounds are going to still remain in there. So this is what they call a new make spirit. When it first comes off the still, it's not been aged in any way, and you would expect the flavour profile to change quite significantly. The other thing we picked out was that the coffee was a quirky and an interesting example to look at. I don't think we were necessarily at any point anticipating the entire whisky industry to stop doing what they're doing and start using coffee. That really wasn't the intention of what we're doing. I think probably more realistically, it may be a combination of other things that you probably use if you were to want to kind of replicate the flavour that peat had. Maybe if you were to take multiple different sources, you could probably get a relatively close match to what you were looking for.
I think the other thing that's worth saying is that the industry is very tightly regulated in what you can actually put into whisky. There might be opportunities for using less way out materials like woods or mosses, which are probably not completely sustainable because you're still harvesting them, but they can be replenished much more quickly than you can replenish peat.
So what's next for the project now?
There are a number of other waste products that are quite attractive to look at, sort of different types of wood and that kind of thing. Maybe looking a little bit more closely at what peat's composed of and whether you could use them as an earlier stage material, so not allowing it to break down for hundreds of years. Could we just use it as it is to begin with? Early on we thought about seaweed as being a good option in that it maps in quite nicely with the story of whisky. It grows by the sea, it's around some of these islands, but you need to be careful about potential toxic compounds that can be released, and do you know that profile? So there'd be a lot of additional work that would need to still be done.
I think what we're trying to do is gather information. What the industry chooses to do with it is entirely up to them. Then the industry are working hard, not necessarily in the alternatives field, but in maybe trying to make the kilning more efficient. So you lose less peat by maybe looking at the temperature in which you burn the peat and the airflow and all of this kind of thing.
I think you need to make, decisions today that will have a consequence further down the line. So
yeah, whiskey bottles are time capsules. If you buy a bottle of 20-year-old malt, then that was bottled 20 years ago. So that reflects the source of the material 20 years ago, not what it's like now. Even if you stop making peated whiskey now, you'd still be able to buy peated whiskey for decades to come.
I think the sustainability factor is definitely a really important thing to be looking into. So thank you so much for taking us through your research. It's been fascinating to hear about it.
Getting to see what goes into the process really demonstrates how alchemy has developed into complex chemistry when it comes to whisky. So what are all these ingredients and processes translating to when it comes to flavour?
We've covered a lot of interesting aspects of the science behind whisky. So now I want to ask you about the physics.
Well, there's a little experiment anyone can do with whisky if you have it in a glass, especially a glass shaped like this one, to demonstrate the physics of whisky. If you swirl the whisky right inside the glass, you're coating the inside of the glass with that liquid, and just giving it a few seconds, you'll begin to see that liquid running down the inside of the glass, but not in a smooth fashion. It's running down in legs or tiers, sometimes they're called, very distinctive in a whisky glass like this. And that's caused by physics. It's to do with surface tension. So the liquid inside this glass is, there's some alcohol and there's some water, and they aren't perfectly mixed. If they were, you wouldn't get as clear legs or tiers in the whisky. The regions where there's more liquid on the inside of the glass is where the surface tension is higher. That's where the water concentration is higher, or there's a bit less alcohol, and the water surface tension pulls that liquid into these linear lines, these legs that you see inside the glass.
And it's really interesting to be able to do that little trick to sort of see what's in the whisky. Do you have any other tricks for finding out what you're drinking?
This whisky that we've got here is smoky to the smell, and I can see that it's smoky. It's also sweet as well, which because it's been in rum barrels, but smoke's the dominant flavour. If you do this, and on you go.
Yeah.
Whisky hand wash.
From you can see the barley.
Wow.
So the flavours coming out one after the other, which I guess is to do with the rate that the aromas evaporate off your hand,
If it's not too mean a question, do you have a favourite whiskey or kind of profile of flavours that you look for?
I'd say that there's three that I return to again and again and again. Glenburgie, which is a distillery which quite hard to come by. A friend found a bottle in a shop, hugely discounted because there'd been a fire, and it was a 30-year-old from the 60s. And I still think about that drum to this day and try to find others like it. mostly I'm disappointed, but it's the hunt. There's Royal Brackla, which is a Highland distillery, which is just so friendly. It's like a hug or a pat on the back. And then there's Springbank. That's the distillery that we've mentioned that they still do things the way they did 100 years ago. And I think that comes through in the flavour.
The whiskies that I've enjoyed the most are ones that I've enjoyed with friends and company and have a specific meaning to me. But I think in terms of a whisky that I wish I had again, a bottle of 37-year-old Bunnahabhain. Yeah, you sold me, Roddy, from North Star Independent Bottlers, and it was like drinking Umbongo. It was like tropical juice, but alcoholic. It was stunning.
We've talked a lot about the rich history of whiskey, but if we go even further back, where does it come from?
To make whiskey, you've got to start with a big bang. When you're drinking whiskey, the whiskey in your glass, all these amazing flavours, they're coming from flavour compounds, and those compounds are made up of elements, and those elements came from stars. When the universe was born 13.8 billion years ago in the Big Bang, all there was, once the universe cooled down a bit, was hydrogen and helium, a little bit of lithium, but mainly that was it. And the first stars were just big balls of burning hydrogen and helium. And in the cores of those stars, they were fusing those elements into other heavier elements. And when those big stars exploded in their final death throes, huge supernova explosions, they scattered all of that other stuff out into space, mixed up with other clouds of gas, and eventually those made new stars. And that's where our star, the sun, came from. So everything inside your glass, all the different elements and all the different compounds, apart from the hydrogen, the H bit in H2O, all of that stuff came from the heart of a star. And the H, the hydrogen, came from the Big Bang.
That's incredible. So there you have it, from the Big Bang to your glass. And I hope you've enjoyed this deep dive into the history and science of whiskey. I've certainly learned a lot. So thank you, Steve and Roddy, for your time. It's been incredible.
Thanks, Rachel.
Thank you.